Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 6-7, Proofs Using Coordinate Geometry. The only terms that we have to cover today are about a midsegment of a trapezoid and the theorem that goes along with it, the trapezoid midsegment theorem. And then we're going to do some of the work from your homework because that's the easiest way to learn how to do this. All right, so a midsegment of a trapezoid is a segment that joins the midpoints of the non-parallel opposite sides of a trapezoid. So if you notice, AB and DC are parallel. So we're going to use the other sides there, and you find the midpoint of each of them, so point P and point Q, and then you connect those two midpoints together, and that is known as a midsegment. The properties of the midsegment are found in the midsegment theorem. There's two. The first is that the midsegment is always parallel to each of the bases, and the second is that a midsegment is, the length of a midsegment is basically the average of the two bases. So you add the two bases together and you divide it by 2. You can also multiply it by a half because that's the same thing. And that is the theorem of a midsegment of a trapezoid. To utilize this information, we're going to put a bunch of trapezoids in coordinate planes. So these questions come from your assignments for this lesson. So this question here has given us a parallelogram, and they are asking us to determine whether or not the diagonals bisect each other. So to begin with, they want us to place the parallelogram in a coordinate plane, and they want us to always want us to put the vertex, if we can. It's easiest to put the vertex here at the origin. Then we want to utilize the rest of the graph as well, so we're going to put one of the sides here along the x-axis. Now, since we're going to be using midpoints in most of these problems here today, we want to use multiples of 2 because that's the easiest way, because we're going to have to find the average. So if you divide something by 2 and it's a multiple of 2, it divides out nice and evenly, and you won't end up with fractions or decimals as your answers. And then to show that the segments bisect each other, all you have to do is prove that their midpoints have the same coordinates. So that's that question. We'll move on here. They want us to find the coordinates for the midpoint of segment ET. So I highlighted segment ET here in red, and we are looking for the midpoint of this segment, the point that comes right in the middle. In order to do that, we'll need to use the midpoint formula. And so let me put that. So we've put that there, and basically all you're doing is find the average of the x points and the average of the y points. So the x point for point T is A, and the x point for point E is 2a. So when you do a plus 2a, you get 3a over 2, which is the same thing as 1.5a. For the y values, we have 0 for the t, and we have 2b for the e point. So that gets us 2b over 2, which is the same thing as just point B. So our answer should be 1.5a, comma, b, which you'll notice it's not this one here, nor is it that one there, but it could be either of the two in the middle. So then they ask us to find the length of segment ET, for which we'll use the distance formula, which I've written down here for us, and then we just plug in our values and solve using algebra. So here the values have been plugged in, and now we're going to simplify. And there's our answer, a squared, the square root of a squared plus 4b squared. All right, so we move on to our next question, which wants the coordinates for points, they gave us the point S, and they want the coordinates for E, M, and O. If you take a look at the graph, what you'll see is that from the origin to this line, you go back negative 3a, and from the origin to the right this way, you go forward positive 3a. And then the same thing happens using the y-axis as well. You go up to positive 2b here, and you go down to negative 2b here. So that information will be very handy. If we want to find point E, remember you always begin at the origin, so we would move back negative 3a, and then we move down negative 3b. So point E here is negative 3a, comma, negative 2b. And then if we want to do point O, we would begin at the origin again. We would go out to positive 3a, and then we would go up to positive 2b. So point O can be found at 3a, comma, 2b. And then to find point M, we'd start at the origin again. We would go out to the right, out here to 3a, and then we would go down to negative 2b. So point M can be found at positive 3a, comma, negative 2b. And those are all the points you need to find for that question. This one wants us to find the coordinates for the midpoints M and N. So we'll use the midpoint formula again, which is just the average. So to find midpoint M, we'll use points R and point T. And we'll do the average of the x values, 0 plus 2b divided by 2. And then we'll do the average of the y values, 2c plus 0 divided by 2. And when you do the math there, what you find out is that your midpoint M is at point B, comma, C. And then we'll do the same thing for the midpoint N using the endpoints A and P. And we'll do the average of the x values, so 2a plus 2d divided by 2, and the average of the y values, 2c plus 0 divided by 2. And when you do some simplifying, what you get is that a plus d, comma, c are the coordinates for point N. All right, and then they want to know the lengths of MN, TP, and RA. So we'll use the distance formula 3 different times. It doesn't matter which one you start with, so we'll just begin with RA. And when we plug in our x and y values into our distance formula, this is what we get, and now we'll simplify. And what we get for RA is that 2d minus 2b is the distance. And now we move on to TP. That's what we get when we substitute in our x and y values, and now we simplify. And what we get is that the distance for TP is 2a. And last but not least, we'll find the distance for MN. And when we plug in our x and y values, this is what we get, and then we simplify. And what we get is a plus d minus b is the distance for MN. And then the last part wants to know whether or not MN is the average of TP and RA. So we take the distance of TA, or TP, which is 2a, the distance of RA, which is 2d minus 2b. We add them together and divide by 2. And when we do, what we get is that we can take a 2 out of both of those, out of all of those rather, and then the 2's cross out, and what we're left with is a plus d minus b, which is exactly the same as what we had for MN. So the answer is yes, MN is half of the average of TP and RA. Good luck, everybody. I hope you guys all do great.